Hey, welcome! Let's think about this for a second. What if the roof of a greenhouse could do more than just, keep the rain out? What if it could actually power the entire farm? Well, today we're going to look at a technology that does just that. It's pretty amazing. Let's get into it. Okay, so here's what we've got on tap. First, we'll talk about the big dilemma with greenhouses. Then, we'll get into the super clever solar solution. After that, we'll look at the balancing act between making power and growing plants, dig into some really surprising extra benefits, and wrap it all up by asking, hey, is this the future? All right, first things first, the greenhouse dilemma. Now, you'd think greenhouses are this perfect solution for growing food, right? And in a lot of ways they are, but there's a catch. A pretty big one, actually. I mean, think about it. These things are absolute powerhouses for farming. You can produce up to 10 times more food than you could in an open field. That's how we get fresh tomatoes in the middle of winter. But all that amazing productivity? Yeah, it comes with a pretty steep price tag. And that price is energy, a lot of energy. Just look at this number. In a cold climate, a greenhouse can guzzle up to 528 kilowatt hours per square meter just for heating. That is a massive energy footprint. And where does that power usually come from? Yep, fossil fuels. So you've got these high costs for the farmer and a big environmental problem for the rest of us.
Okay, so that's the problem, and that leads us right to the solution. This is where it gets really cool. The big idea here is asking a simple question. What if the roof could be more than just a roof? What if it could become the power plant for the whole operation?
And there's a name for this idea, agrivoltaics. It's really an elegant concept when you think about it. You're basically taking the same piece of land and making it do two jobs at once, grow food and generate clean electricity. Putting solar panels right on a greenhouse roof? That's agrivoltaics in a nutshell.
So you're probably wondering, how does that even work? Don't plants need all the sun they can get? Well, here's the secret. Plants are kind of picky eaters when it comes to sunlight. They mostly care about the red and blue parts of the light spectrum for photosynthesis. All that other stuff, the green, the UV, the infrared, a lot of it just creates extra heat they don't need. So, the genius of agrivoltaics is that you can design panels to let that good red and blue light pass right through to the crops, while capturing all that leftover light to make electricity. It's like sharing the sunlight.
But, this whole idea of splitting up the sunlight, it leads to a really important choice. It's a constant balancing act. How much energy do you want to generate versus how much light do your plants need? It's like a friendly competition between power and plants, and there are basically two different ways to approach it.
So, your first option is using regular opaque PV panels. The standard dark solar panels you see on rooftops everywhere. They're amazing at making electricity, but they block all the light, creating a ton of shade. That's not always great for crops. The other option is using semi-transparent panels. These are specially made to let some sunlight through for the plants below. The catch? They don't generate as much power.
And this table really breaks down that trade-off with some solid numbers. Look at the opaque panels. If you cover just a fraction of the roof, say 20 to 40%, you can still generate a ton of energy, up to 203 kilowatt hours per square meter a year. Plus, they have this great side effect of cooling the greenhouse down by 3 to 5 degrees, perfect for crops that like a little shade, like lettuce. Now, the semi-transparent ones, they generate less power for sure, but they let in way more light. So they're the go-to for sun-loving plants, like tomatoes, and they still give you a bit of a cooling bonus.
And it's not just about what panel you use, but how you arrange them. The layout is a really big deal. You could do a straight line pattern, but that might shade the same plants all day. Or you could do something like a checkerboard pattern, which spreads out these little patches of sun and shade all over the place. As the sun moves, every plant gets a mix of both. It's all about smart design. The architecture really matters.
Okay, so we've talked about the power, but here's where it gets even more interesting. There are all these other surprising benefits that have nothing to do with electricity. It's way more than just a power source.
For starters, what about water? This is huge. Because the solar panels provide shade and lower the temperature inside, the plants don't lose as much water to evaporation. We're talking about potential water savings of almost 30%. In a place that's struggling with drought, a number like that isn't just a benefit, it's an absolute game changer.
And get this one is really wild. Some of these panels can be designed to block UV light. So what, right? Well, it turns out a lot of pests and plant diseases actually use UV light to find their way around and reproduce. So by blocking it, the roof itself becomes a kind of passive pest control system. You can actually reduce the need for pesticides. How cool is that?
But at the end of the day, the numbers have to make sense for the farmer. And the good news is, they can. For certain setups, especially with the opaque panels and a sunny climate, you could see a payback on your investment in just 5 or 6 years. When you think about it, generating your own power and cutting down on other costs, it can be a really smart business move.
So the big question is this really the future of farming? Let's wrap things up by looking at what's next for agrivoltaics, because it's not all smooth sailing. There are definitely some challenges to figure out.
Yeah, getting this technology everywhere isn't going to be a walk in the park. For one thing, the upfront cost can be pretty high. And for some of the newer, transparent materials, we still need to be sure they're going to last for 20 or 30 years up on a roof. Then there's that constant balancing act we talked about, getting the most power without hurting your crop yield. And of course, getting a little help from government policies, like tax breaks, would definitely help things move a lot faster.
This quote from the research just hits the nail on the head. It says that the main challenge is finding that perfect, optimal balance between making electricity and growing great crops. That's the puzzle that scientists and engineers are working on right now. Every new material they invent, every new layout they test, it's all about getting closer to cracking that code.
So we'll leave you with this thought. Will our future food grow under a solar-powered sky? It's a pretty powerful vision, isn't it? A food system that's more sustainable, more resilient, where our farms produce not just food, but clean energy too. The technology exists, the potential is absolutely enormous. So really the question isn't if this can happen, but how quickly we can make it a reality. Thanks so much for tuning in.